Okay, in the Identify and Graph Linear Functions notes, which is chapter 2.1 in your textbook, a relation is a pairing of input values, x values, with output values, y values. These are sets of ordered pairs. In that relation, you have your domain values, which are your set of input values or x values. You have your range values, which are your set of output values or y values. And if it is a function, if the relation is a function, it's when every input, every x value, has exactly one output. You can use the vertical line test to determine whether or not a relation is a function or not. Okay, for example 1, would you please try to record the domain, range, and whether or not the relation is a function, and tell the reason why. Then turn the recording back on and check that you got the right thing. So turn the recording off before you see the answers. Okay, now going over this, the domain in numerical order is -1, -2, -3, -4. The range is 1 and 5. We do not write 2 1s and 2 5s. We only write the number one time. The relation is a function because for every input x, there is exactly one output y. There are, the vertical line test would show you this, but you can also see that there are no repeats of numbers in the x or the input column. Okay, now try example 2, writing the domain and range in order with no repetitive digits, and then write whether the relation is or is not a function and the reason for that. Okay, for example 2, the domain, the input or x values, are 0, 2, and 4. We don't write the repetitive numbers. For the range, there were no repeats. In order, it is -4, -2, 0, 2, and 4. This relation is not a function because for each input, there are several outputs, meaning there are more outputs than inputs. So for every input, there's more than one output according to the official definition. Now, you're going to use the vertical line test on this particular graph right here to determine whether that graph represents a function. And then you're going to write the graph is or is not a function and the reason why. Use the formal definition. And then in this next one, you're going to explain how the strategy of using the vertical line test works to distinguish functions from relations that are not functions. As we look at this coordinate graph, for example 3, we can see that if we were to physically draw vertical lines in, that it would only have a point here, a single point here, a single point on this line here, and a single point on this line here. I could draw an infinite number of vertical lines, and they would all have one single point. For that reason, it is a function because for every input value, every x value, there is exactly one output value or one y value. Now this next question is a little more high-level thinking, so we need to explain why the vertical line test works to distinguish functions from relations that are not functions. If the vertical line has one point, it is a function, just like this one. There's one point on the vertical line, it's going to be a function. If the vertical line, or it, has more than one point, then it's not going to be a function. I'd like you now to move on to the second page. And the directions for this are, for example 4 and 5, write the relation as a set of ordered pairs, then graph the relation and tell whether it is a function. So I started you off. This is one of those odd-looking input-output tables that is only used when the author wants to know whether it's a function or not. So the first ordered pair is 4, 2. I've written it. You need to write the remaining ordered pairs, graph them. You can use any strategy you want to determine whether or not the relation is a function, and then write the reason why. Write the rule, not the strategy that you used. Okay, after the ordered pair 4, 2, you had the ordered pair 4, 3, the ordered pair 4, 5, and the ordered pair 4, 6. Once I plot these, I can see that if I do an imaginary vertical line and use the vertical line test, that there is more than one. You can see there's 1, 2, 3, 4 points on that vertical line. Therefore, the relation is not a function because for every input there is more than one output. The vertical line test is not the only test you can use. You can say there are repeats in the inputs. So there are, for every one of these outputs, there's the same input, the same x value, and therefore it is not going to be a function. What I'd like you to do now is try example 5 and write all your ordered pairs. Make sure they're in parentheses and separated by a comma. Graph it. Do not connect the points. It is a discrete function. And then tell whether the relation is a function or not, and the reason why using the formal definition. Okay, for example 5, negative 6 is one ordered pair, negative 4 is another, negative 3, negative 2, 0, negative 1, 3, negative 2, and 4, negative 4. You would have graphed these points, and I went ahead and put the imaginary vertical lines through them. Again, the vertical line test is only one strategy for determining whether a relation, this is a relation right here in example 5, is a function. In this case, because there's only 1 point per line on those imaginary lines, we know for certain that it is a relation. So, that it is a function. The relation is a function because for every input there is one output, or there's exactly one output. Now, I showed the vertical line test, but some of you use the strategy of looking at the inputs, the x values, and if there are no repeats, that's going to mean that for every input there is exactly one output. All right, with that said, one of the things that you need to be able to do as you get into your IB mathematics classes is to use some logical reasoning. And these are, and you'll also see them on the SAT test if you're considering taking that test in order to go to a U.S. university. So it says use logical reasoning to fill in the blank with always, sometimes, or never. So for example 6, it says a relation is blank a function. So you would say a relation is always a function, a relation is sometimes a function, or a relation is never a function. So take a minute to think about that. As soon as you've had a chance to think about it, then turn the recording back on to see if you got it right. A relation is sometimes a function. You can see from examples, there were previous ones, but you can see from example 4 that because it had the same input value for every one of the output values, it was not a function. So the relation was 4, 2, 4, 3, 4, 5, 4, 6, but because for every input of 4, it has many outputs, that is not going to be a function. On the next one, example 5, you saw that for every input, they were all different x values, there was exactly one output. Therefore, that relation was a function. So a relation is sometimes a function. Letter B says, this is example 6 again, the first coordinate of an ordered pair is always a number in the domain, is sometimes a number in the domain, is never a number in the domain. Now the first coordinate is always going to be your x coordinate. So take a minute and think about that and turn the recording back on when you've decided. Your x values are always your input values, and your input values are always going to be your domain values. So the first coordinate of an ordered pair is always a number in the domain. Now you have some graphing that you have to do today, so I need you to have 6 graphs. You can always get them off of Schoology under the general folder. It'll be in there. Or you can get them from me, whatever you decide. So now we're going to go ahead and do some graphing problems, which will help you with this part of the assignment. But if you've been absent, this is how I want you to set up your assignment. On a piece of notebook paper, please put your name, block, and date. You'll be doing pages 70 to 71, 15 through 18, 22 through 23, 27, 29, 30 through 34 even, that means 30, 32, 34, and then all of the problems from 36 through 41. In 36 through 41, you will be graphing, so you're going to need to choose 3 domain values, 3 x coordinates, and then find your y. Be careful that it fits on your 10 by 10 coordinate graph. So we're going to go ahead and do one of those right now. So make sure you have your coordinate graph paper in front of you. Okay, you have to do 36 through 41. I'm doing 40 with you, so you only have 5 graphs left to do after this. The problem for number 40 is y equals negative 2x. So all we do, and this is a mental math problem, so I'm allowing you to pick the domains. I pick -1, 0, and 3. You can pick anything that will fit on the graph as long as your output is within that 0 to 10. So we substitute in the -1 that I have for my x value. -2 times the substitution of -1 is going to be +2. So we're going to go ahead and write positive. We're going to go ahead and, let me get the pen. So we'll go ahead and write +2 there. Let's go ahead and change this color back to red. And go over this +2. Okay, so we have -1 and +2 plotted on the graph. Then we go to 0, substituting 0 for the x value. -2 times 0 is 0, so your y value is 0. Easy to plot that. 0, 0, it's at the origin. And then finally you have 3, -2, substituting in the 3 for the x value gives you -6. And so we have 3, -6. Plot that. Now, you do not connect these points. That would make it a continuous function. I'm only asking for a discrete function, so you just plot the points. I will expect to see 3 points on all of your other graphs from 36 to 41. Again, 40's been done, don't do it over again. If this recording has been helpful and you start to get stuck, go back and look at the recording again. You can also come and see me during remedials if that is something you need as well.